Good afternoon, everybody. We are here today to meet the professional. This is our second Meet the Pro workshop. And today we're going to be welcoming Dr. Shelly Peyton, chemical engineer at the University of Massachusetts. Good to have you, Shelly.
Thanks. Great to be here. Thanks for inviting me, Matt.
Absolutely. Dr. Peyton has been a site host for our STEM at Work program internships the last 2 years. And I know students have really enjoyed being with her. Dr. Shelly Peyton is an associate professor in the Department of Chemical Engineering at the University of Massachusetts, Amherst. She earned her bachelor's in science from Northwestern University in chemical engineering, her master's and PhD in chemical engineering from the University of California, Irvine, and she did her postdoc in biological engineering at MIT. Dr. Peyton is head of the Peyton Lab at UMass, whose mission is to learn how cells process information from their chemical and physical tissue environment. They design polymeric biomaterials to create models of human tissue and use them to study how cells move, grow, and respond to drugs in different tissue environments. They use this approach to find new ways to stop cancer metastasis, discover more effective cancer drugs, prevent heart disease, and build scaffolds for regenerative medicine. Is there anything else you'd like to add to that?
No, that's everything. I can tell them a little bit more about my path as well when I take over. That was great. Thanks, Matt.
Excellent. Yeah, no problem. So I'm going to turn it over to you at this point. I think I shared some questions with you prior to this meeting today. Just part of the purpose of this is to help kids understand how do people go on to become the professionals that they are most of their careers. So if you could just maybe share a little bit about how did you become first interested in chemical engineering?
So I don't know if I did that in a really smart way, right? In high school, I went to high school, well, half in Wisconsin and half in Kentucky. My family moved around a lot when I was a kid. And I got interested in a lot of different things. I was interested in music. I was interested in French and studying French. I thought maybe I would do one of those things. And then I was also kind of interested in chemistry. I liked my chemistry classes and professor a lot in school. I had taken a lot of math and liked that, and a little bit of physics. I only had like introductory physics, but I liked it okay. And I thought, well, what would be a better path to a job, like following French and music, or maybe something in my more STEM focused studies? So that's why I kind of maybe pragmatically decided to go down the science path. I really liked chemistry and I liked math, and physics was okay. And so I thought, putting that together, that sounds maybe like chemical engineering. I was just kind of like using the internet to see what different majors were possible at different colleges. And it seemed like mushing those three things together sounded like chemical engineering. So that's why I chose that major.
And so what kind of experience did you have in high school doing this kind of stuff?
Yeah, mixed. Like I really like the chemistry lab, like being able to get my hands dirty and kind of play with the chemicals and things. And I remember talking to my guidance counselor at my high school in Kentucky. And I said, hey, I'm thinking about maybe majoring in chemical engineering. And she said, oh, don't do that. That's too hard. And I think that actually was kind of motivating for me.
Yeah.
It was like, I'll show her wrong, that I can really do this. And I tend to have kind of a stubborn personality. But I didn't know anybody in my family that did anything like this. I was the first in my family to go to college, so we didn't really have an idea of what that was going to mean, but seemed like it could be fun. So I thought to try it out.
Well, that's amazing. So how does your family think about you being now a PhD and somebody who leads a lab?
I think they think I'm smarter than I really am. I think all of us are trying to find something that we enjoy. And that's the most important thing, right? So I kind of found a path and tried out a few different things within chemical engineering and found the stuff that I thought was the most fun to do. And that's really helped me pick what to keep at. Because I think no matter what you're doing, things can get hard along the way, right? Some homework sets can get hard. You're not always going to have the best teachers or professors. And so it's really important to do what you're really enjoying, no matter what that path is. And that'll really keep you motivated to keep learning and exploring if you're having fun at the same time.
Mhm. So when you started college, how did you, I mean, because you went on for a fair amount of additional education, how did
Yeah.
you decide that you just wanted to keep going? Did you have a goal in mind that you were shooting
Yeah,
for? Or
I
did you
did. Yeah,
follow your interest?
I did. It's a good question. So, when I was starting in college, I I learned more about what it meant to be a chemical engineer. Like, what are the jobs that are out there? What are people really doing with that degree? Because it's not something you really know going in to choosing any major. Like, what are people doing on a day to day basis? And I think chemical engineers are doing a lot of different things, right? I mean, people
Mhm.
are working in alternative energy, like using microbes and organisms to make fuel, right? They're working a lot in clean air and clean water, trying to find better ways to get the junk out of air and water. They're working a lot in developing new materials, like developing materials for solar panels or fuel cells, or even new materials that go into microprocessors and computers, right? Um, and then what I got really interested in was seeing that, oh, you could apply the things that you're learning in chemistry and in math to really interesting problems in biology and human health, right? And so I didn't really want to be a biology major because I don't know, and maybe the students on the call might have some ideas about this too, but I always found biology to be a lot of memorization, and I really don't have a good memory. I'm not
Mhm.
very good at like test taking where you have to memorize a bunch of stuff and then put it on paper. I'm much better if I can like figure it out along the way. So I wanted to stay being an engineer, but being able to apply that to solve problems in biology. So that was kind of my first hint that maybe I would take my chemical engineering degree into something like cancer and human health. And then the other thing I learned about myself is I don't like getting up early in the morning and I don't like dressing up. So I saw a lot of people that like when they go to a job, they've got to get there by 8, they have to wear business professional clothes. And then I saw my professors and they make their own schedule, right? They teach at certain times, but really they can come in and leave work whenever they want and they don't dress up that much. And so those were like the really beginning things. I was like, oh, that might be a good fit for me. If I can like stay up late and sleep in and then not have a boss to answer to, I think I want that job. Right. And so that kind of motivated me to keep going to graduate school and then do a postdoc so I could eventually have that job that seemed like a good fit for my personality.
That sounds very cool and correct, and correct in the sense of like, I want to emphasize for the students, you really should. What I hear you saying, Dr. Payton, is that you're through your path, you're doing a fair amount of self-reflection about what worked for you and what you were interested in, and you weren't really. I'm not hearing anything about somebody said you should.
No. Yeah.
You were just thinking like, well, you know yourself well enough to know that you didn't want a job where you had to show up at 8 o'clock at a desk and be there for the boss looking over your shoulder. And I think understanding who you are as a person and kind of staying true to those truths about yourself really does make for a happier fit in a career path.
Yeah, absolutely. I think
Yeah.
that's exactly right.
So I'd love to hear, I know you have some presentation, some slides to share. Do you want to try to flip over now and do the presentation,
Yeah,
show
well,
us
I
some of your work?
thought, for before I do that, I want to talking about my work. I thought maybe I would
Sure.
say a little bit about, students maybe choosing colleges and thinking about how to make a path. Like I said, I was moved around a lot as a kid. I was born in Kansas. We lived in a small town, about 4,000 people. Then we moved to central Illinois, then to Wisconsin, then to Kentucky, then to Minnesota. And we always lived in these really small towns. And so, like, a really seemingly trivial decision that I made. I was like, well, when I go to college, I want to go live in some big city.
Mhm.
So that's why I ended up going to do my undergrad at Northwestern, because it was in Chicago. And so like I wanted to live in, in some city environment. And I think that's a fine way to choose where you're going to go. I think there's a lot of undue stress and pressure about thinking about like, where am I going to go to school? I think there's a lot of factors that play into that. Like, can you afford it? Do they have the majors that you want to study and enough opportunities? And you can't really make a wrong decision.
Mm.
All these places are going to have lots and lots of opportunities for you. And it's more important to, once you get to whatever college you're going to take advantage of the opportunities that are given.
Yeah.
And then I went to grad school at the University of California, Irvine, because I wanted to live on the West Coast, right? And
Mhm.
so I wanted to be able to experience that at some point in my life. And I think it's really good that I did. And I realized that I don't want to live there for my
Mhm.
whole life, right? But it was a really good thing to experience for a little while. And then I ended up in New England and Boston and really fell in love with Massachusetts and the type of people that are here, right? So that really influenced me wanting to stay in this area. And I've worked or been a student at 4 different universities: Northwestern, UC Irvine, MIT, UMass. They're all equivalent, right? They all have amazing opportunities. They have everything that you'd want to study. Be open-minded about all the places you can go. And if you're thinking about maybe going to community college first and transferring into a school, I have a lot of students that work in my lab that have done that. And I think that's a really great path as well to help save some time and money
Mhm.
before committing to a big university. I think that's a great path. And it doesn't really matter which path you take, just find something that fits for you, right?
Yeah.
Um,
Our guest last week was Dr. Juan Jimenez, and he was from UMass, and he was saying something similar, where he was in favor of um, students worrying less about the specific school, the specific name of school, and just getting into something that makes sense for you financially,
yep.
that you can afford, that you're happy to go to. And when you're there, no matter where there is, make the most of the opportunities presented to you. And I thought that was a good bit of advice.
Yeah, I think that's perfectly right. Like, I don't think, I mean, anything you would ever want to do is at UMass, right?
Yeah. Yeah.
Um, the same goes for these other places. It's not like one's going to provide you better opportunities than another. It's really about what you do and how motivated you are once you get to that place.
Yeah. Yeah.
And as far as, people thinking about like, what is chemical engineering? I mean, I listed off a bunch of things you can do, and I'll talk about what I do with that degree. But I also think it's like a pretty lucrative educational path as well. So for people that are just graduating with a bachelor's degree in chemical engineering, what I'm seeing from the graduates at UMass is their starting salaries range anywhere from $60,000 to $120,000 a year, and that's just with a 4-year education. So and our job placement rate is basically immediate.
Wow.
Right. Students are getting jobs right after they graduate, or they're lining up their positions well before they graduate.
Wow.
So it's definitely something, if you're just thinking pragmatically, it's a really good major to get into at this point if you're interested in any of these things, or like chemistry, math, physics, those types of things.
Yeah. Thank you. That's an important point to make, I
Yeah.
think, is not only what is the job market like for a recent graduate, and it sounds like it's about as strong as it could be, but what's the long term? I mean, you already mentioned, like, people with chemical engineering backgrounds can work in, you know, uh, green technologies, new types of technologies, technology itself in the form of computers,
Yep. Yep. A lot of people on like
medicine.
alternative energy,
Yeah.
right? And thinking about like wanting to clean the environment, like doing chemical engineering is a great way to do that. It's what we see a
Yeah.
lot of our majors ended up doing. And alternative fuels, like people worrying about climate change and what that's doing. A lot of chemical engineers are, not really working in the petroleum industry anymore, but instead shifting over to saying like, well, what's better? What's the next generation of technology going to be so that we can get away from fossil fuels? That's really dominated by chemical engineers. And then, a lot of people working at the interface of like engineering and health, right? I think
Mhm.
that's an area, Professor Jimenez, who talked to you last week, he works in that area as well, right? biomedical engineers and chemical engineers. I would say chemical engineers are mostly focused on designing better and cheaper drugs. So they're working in sort of the pharmaceutical industry. And the focus here is like, how do you make these drugs cheaper? How do you get them to the people that need them? How do you get cancer drugs to be less toxic, right? So that you can kill cancer, but not kill the person, right? So that's an area of intense focus for chemical engineers as well. So it's a really nice area of study to use as a jumping off point or a platform to study lots and lots of different things throughout your life.
Cool. Very nice. Do you want to try to talk about your work at this point?
Yeah, let me see if I can present my screen. I think you're presenting now. Is there a way that I can switch that off to do?
I think if you look on your bottom right, put your cursor down, your mouse down, your bottom right, it should pop up and say present now.
Okay, so I'm going to go here. So I hope people, if they have questions, please just talk at me. This is like a set of slides that I had taken. I had traveled to Cincinnati recently to talk about my lab's work. And so I pulled out a couple things here that I thought would be a good overview of what my group does. Please stop me if you have questions or put them in the chat box. And then maybe, Matt, you could see the questions and
I'll watch for them.
Tell me what they are. Awesome.
I also want to make sure, can somebody just let me know on chat, can you see her screen? Because as the main presenter, I can't. So let me know if it's coming across clear. Yep, Kieran.
Yeah,
Kieran
they can see it?
Yep.
Okay, awesome. Okay, so I use engineering to make soft, squishy gels. And we are making these soft, squishy gels as representatives of human tissue, okay? To you and me, they don't look anything like a human brain, but to cells that are living in these soft, squishy environments, they think they're in the brain, okay? So we can basically use these to study what cells do in different environments, and we're trying to apply what we learned there to cancer, okay? So I'll give a little brief overview of cancer. So we study breast cancer, and these are the statistics that have emerged from, well, it's for women in the US and Europe. Okay, so not necessarily exactly the same for people in Africa or Asia, okay? So 1 in 8 women are diagnosed with breast cancer at some point in their lifetime. It's a huge number. So we all know someone that's been diagnosed with breast cancer, likely some, at least extended family member. It's a really prevalent disease. And breast cancer, like other cancers, it is a disease of mutations in DNA, right? So this is true about all cancer. And I bet students in the room have learned a little bit about this, maybe if they've taken like an introduction to biology class. So when cells in the body divide, they have to replicate their DNA, right? Every cell has DNA. To make a new cell, we've got to make new DNA. Every time a cell makes DNA, it makes mistakes. It's rare that they're making mistakes, but they make mistakes on accident. And most of the time it doesn't matter. Like you probably have mistakes in your DNA all over the place. It really doesn't matter because it's not in a gene. It doesn't control what the cells do. But if a cell can make enough mistakes in its DNA, or if there are things that you're exposed to in your environment, like smoking or UV exposure from the sun, that can also cause mistakes to happen in the DNA of a cell. And sometimes those mistakes cause the cells to grow faster. Okay? So it gives these cells that have mistakes in their DNA a growth advantage. And now you have more and more cells with those same mistakes. and they grow and grow and grow out of control. Okay.
Mm.
So cancer is really a disease of uncontrolled cell growth. It's just like I'm doing a lot of gardening right now during the quarantine,
Mhm.
right? And one big thing when you're growing a garden is you want to get rid of the weeds, right? Because the weeds grow a lot faster than the stuff you're trying to grow. And those weeds are bad because as they're growing really fast, they take all the nutrients from the stuff that you're trying to grow. That's the same thing that happens in cancer. Okay. These tumors will grow really, really quickly, and they themselves might not be that bad, but they're sucking all the nutrients away from your healthy cells, which is why it causes some tissues to die in your body. And that's why cancer is so bad, right?
Mm.
So in breast cancer, breast cancer is somewhat unique in that if you were to have a tumor in the breast tissue, what if you can catch it early enough, it can really be dealt with quite efficiently, right? So you can remove the tumor from the breast. You could even remove the entire tissue, right, and have what's called a mastectomy or a double mastectomy or even a radical mastectomy, which takes all of the surrounding tissue as well. It's a very painful process, but if you can catch it and get rid of the whole tumor, you will survive this disease. And treatment for breast cancer has gotten a lot better in recent years, particularly in the US and Europe, because we're doing a lot better at catching it very early, right? That's really critical for breast cancer. The danger about breast cancer is because it can metastasize. So Matt brought up this earlier that what my lab studies is metastasis. And what that means is the ability of cells to leave that primary tumor environment, so the tumor in the breast, and they can spread to other tissues. So breast cancer will spread to the lymph nodes, it spreads to the liver, the lung, the bones, and the brain. And although you can remove the tumor from the breast or even remove the whole breast, it's really difficult to do surgery in these other areas. So if you get a tumor in the brain, it's often thought to be untreatable, right? So a lot of current treatment, unfortunately, is giving very, very toxic drugs to patients to try to kill these cells that have distributed all over the body. Surgery is really difficult. It's really difficult to take tissue out of the brain because obviously you can't live without brain tissue, right? So this is when this disease becomes deadly, is the ability of it to spread to these other tissues. So that's what we're studying, not what the cells are doing here, but why do cells get to these other environments, and what do they do there, and can we kill them more effectively once they get there? So this is what my lab does. We use engineering approaches to build synthetic environments. We're essentially doing tissue engineering to build synthetic environments of bone and lung and brain. Okay, because then we can study how cancer cells from the breast interact with their environments once they get to these tissues. These are all made of synthetic polymers. So this is just a name of a polymer. This material is found everywhere. In human technologies, you'll find this in antifreeze. If anybody's taken Miralax, I don't know if people are familiar with Miralax, but that is just polyethylene glycol. It's a lubricant, essentially, to clear your system. And you can make these engineered tissues out of that innocuous material, and it interacts really well with cells. And then we can tune the chemical properties of that synthetic polymer environment to make cells think that they're in the lung or the bone marrow or the brain. And then we can study what they do there. So this is just, I thought I'd show a picture of like what it looks like for cells to be in these environments. So everything that you see here that's sort of transparent or translucent, that's the synthetic environment that my lab has engineered. This is an example of I think it's a bone marrow environment. I can't quite see my caption here at the bottom, but I think it's a bone marrow environment. And then all these cells that you see that are either green or red, those are breast tumor cells. These are cells from a very aggressive form of breast cancer. So what we're doing is we're watching what cells do in these environments. So you can see down here at this bottom cluster of cells. So each small thing right here, that's an individual cell, and this is a bunch of cells that are grouped together. So we've formed these in a way that's mimicking a small tumor that's formed in the bone marrow. And what you can see is these individual cells sort of migrating out and then starting to divide a bunch, right? So they're forming this really aggressive behavior in this distant environment. So not an environment from which they originated, right? So we're trying to study this, like how fast they're growing, how fast they're sort of invading into that space. And then we're also trying to develop drugs to kill cells once they get in this environment. And so a good example of that is maybe looking at this spheroid here. The green that you see, those are cells that are alive. And then in the middle here, you can see that actually some of these cells look red, or they look yellow because they're both green and red. Those are cells that are dying, okay? So we're trying to screen drugs, hit these cells with drugs in this bone marrow environment to find out like how many of these cells can we kill without killing healthy cells. So we're, both combining other healthy cells in this environment to see if we can kill these cancer cells without killing the healthy cells. So that's kind of what we're studying. And then we're doing this with a lot of different environments. So these are basically the synthetic polymers. You mix them together and you make this bone marrow mimicking environment. We share these materials with people all over the world that are looking for better environments to study how cells behave. So we've done some 3D printing in the lab to make these little kits that we can mail to people, right? So we send these bone marrow environments to folks. We have lung mimicking environments. We have brain mimicking environments. We've also worked on thymus. We collaborate with some people who are studying thymus cancer and other thyroid diseases. And so we're making these synthetic environments to study how that works as well. And so that's what we're doing. We are always looking for new students. And as Matt said, I've really enjoyed working with the collaborative to have interns from high schools in the group. We've hosted 4 of them so far, and we also have a separate high school student training program that we run every summer where we bring in anywhere 2 to 4 additional students into the group, and you would work with me and lots of other folks in the lab to do science. And we're asking lots of different questions as we work on these things. We're making new, different types of networks to study cells in better ways. We're trying to target different things to stop how breast cancer spreads. We're trying to understand why breast cancer spreads to those tissues and not others. Like, why don't breast cancer patients get metastases to the kidney, right? Or to the bladder? You never see that. And we don't really understand why that is. And then also thinking about how tumors change over time in different tissues in the human body. And does that mean that someone with early stage breast cancer might need different drugs than someone with late stage breast cancer? So those are the kinds of things that you might work on if you ended up wanting to work in my lab over the summer, and we'd love to have you.
Thank you, Shelly. That's a great introduction to what you're doing. It's pretty fascinating. I mean, I never, that is kind of what I was thinking when you showed the pictures of the body and the roots of metastasis that happen. But I had never imagined that there are some organs that cancers don't go to, or that particular cancers metastasize to specific organs.
Yeah.
So that's a fascinating.
And it's pretty interesting because we've known that since 1880.
Really? God.
Yeah, there was a surgeon in London that discovered this. They looked at all these different patients that had cancer, like different types of cancer, and he noticed, wow, if you have prostate cancer, it seems to only spread to the bone and maybe a couple other places, but breast cancer have them in these places, and esophageal cancer goes to these places. So we've known this as a community for 130 years or so, and still have no idea how this works. So it really I think shows that we need different types of people, people coming from different backgrounds to study this problem in a new way. Just coming at it from the biology angle has not been enough. Like we need
Fascinating.
people with engineering backgrounds or physics backgrounds or a lot of mathematicians to figure this out from a different angle.
Hmm. Any, just out of my own curiosity, any ideas about how it's metastasizing? Like
So
what the roots are?
yeah, so I would say a hypothesis, my hypothesis is that these cells get everywhere.
Mm.
Your whole body has blood vessels, right? So the cells can get everywhere because they have all these highways. But for some reason, where they land may or may not be hospitable soil. Right?
Mm.
You think about putting your seeds in different places in your garden. Some seeds need acidic soil, some needs basic, some can grow everywhere, some needs lots of sun, some needs shade. It's really about the relationship between that cancer cell and how nurturing that destination soil is will tell that cell if it can grow or not.
Mhm.
Right. So that's why we're trying to engineer these environments to see which ones are helping them grow.
Very cool. Let me just open up to the students here. Do we have any questions from the students about really anything that Dr. Peyton has covered? Please feel free to chime in and remember to turn your microphone off. Yes.
Hi, Miss Peyton. First of all, I was going to ask like if you're going to be like in the STEM field, what kind of like jobs can you get like in the future if you like science, technology, engineering, and math?
Yeah, I mean, I think that the sky is the limit. So I think, graduates from UMass that have gone from STEM fields, they work in research labs like what I'm doing. They work at drug companies. A lot of them work in new materials development. They work at big companies like IBM, right? They work at small companies like startup companies who are developing the very first drug of its kind to treat some disease. So it could be a company of 5 people, it could be a company of 30,000 and everything in between. A lot of students are going into management with their STEM degrees as well. So at UMass, there's a really nice partnership between the science majors that you can do and the business school. So people thinking about, I want to, run a company or be a manager at a different place, or I eventually want to go to business school. But with these science focuses, that can be a really good path as well. But I mean, my bottom line is like with a science or engineering major, you can do anything. It's a really nice platform to be able to go into lots of different fields.
Exciting.
Thank you.
Who else has a question? And when you do ask your question, make sure just to that you're close to your mic and that you're speaking up.
No questions too small. You can ask me anything.
Yep.
Okay, I have another question.
Great.
So if you go to college, can you like just go for like a major in like what you want to do? Let's say like you want to be an accountant, can you like pursue accounting? Or can you do like STEM program, then when you're done, because like you did math in the STEM program, then use that as part of your accounting, job seeking, whatever.
Yeah, you could do both. Like you could major in something very, very specific. Like my sister-in-law is an accountant and went to school exactly for that. You could also be more general and major, like you mentioned, in math or major in statistics or in like data science, right? Those are all kind of related things. And that might be a broader thing to study because if you're like, well, I'm pretty sure I want to do accounting, but I'm not necessarily, I want to keep my doors open, then doing something a little bit more broad could be useful because it would allow you the opportunity to change your mind later if you wanted to, in case something else came up that you found really interesting.
Okay, thank you.
Mm-hmm.
Hi, I'm wondering how much of your work is like collaborative versus more independent, and maybe how that's changed along your career as you go through different stages?
Sure, great question. So all of my projects are collaborative. And that has been the case the whole time I've been at UMass. It's actually one of the reasons that I really wanted to come to UMass. Like, I had job opportunities at a variety of different places. So one of the things I was thinking about is like, well, where do I want to live? Because, when you're searching for jobs, sometimes you have to be open-minded to living anywhere. And so as I said in the beginning, I really wanted to live in Massachusetts or somewhere in New England. So I was happy from that angle. And I also was looking at, well, what place is full of a lot of team work and team science, and what places seem to be more like each lab does their own thing and pursues their own industry questions. And I think both approaches are totally valid. I really enjoy working with people because I have my own training and my own ways of seeing the world. But other people from different backgrounds and perspectives like bring really different perspectives and ways to approach science than I do. So I like working with lots of different types of people. And at UMass, it's really collaborative. It's really easy to work with other people. Everybody's really excited to work on new, interesting projects. I just had a meeting yesterday with a faculty member in chemistry, and we're going to take a joint student together because we're like, hey, it would be really cool to work on this. Let's try it. Neither of us have done it before, but this is a cool opportunity. And I found that that was really part of the fabric of UMass. And so I don't have a single student that works only by themselves. They all work with multiple people and multiple PIs to help broaden what they're doing.
That's where your soft skills come in, folks.
You're always no matter what you do, you're gonna have to work with people, right? And some of those people are gonna be easy to work with, and some of them not so much, right? So and so it's doing it a lot can help give you practice on working effectively in teams.
Yeah. Aisha, is that you wanting to ask a question?
Yes.
Shoot.
I was wondering, how do you have high school students contribute to your work? During internships, what do you have them do?
Yeah, so good question. So like I said, so last year we had four or six. I'm getting the years mixed up a little bit. It's either 4 or 6 high school students in the lab last summer. And I also have a high school student that works with me during the school year as well. That's a little more rare because usually you have too much stuff going on already. And so it's a little hard to figure out how to work in the lab and be a student during the semester. But during the summer, it's much easier. So what I do during the summer is first we have a day where we're figuring out what everybody's interested in, because there's a lot of different projects going in the lab. And some students come in and they're more interested in sort of the chemistry side. And some students come in and they're more interested in the biology side. And so I try to fit people into where their interests are. And then what I do is I work with a graduate student in my lab to develop a project that high school student can contribute to in a fulfilling way within a short summer period. Okay. So typically the first 2 weeks, all you're doing is learning, right? You're learning how to use the pipette. You're learning how to culture cells. You're learning how to make the materials. You're learning how to use the microscope. And then after that, we sort of push as much as possible for you to work on your own. So every week we'll have kind of a goal. So hopefully you can figure out how fast these cells are moving in this environment. So you know how to use the cells, you know how to use the microscope, go try it. And typically people are going to make a few mistakes, and that's okay. And data won't happen for a while, but ideally by the end, you'll have one new discovery that the lab didn't know about before, even in a short-term thing. So a lot of training up front and then independent by the end.
Okay. Will you be taking any internships this summer?
Yep, assuming Matt can find me some good students.
I'll definitely find you the students. I don't.
Yeah, so I don't know what's going to happen this summer, right?
Yeah.
So this summer is really tricky because we don't know when the shutdown's going to end, right? So the last I heard, was that we're shut down to at least May 4th. I would be pretty surprised if that doesn't get delayed even more,
Yeah,
right?
I heard that in other states like New York, they've delayed it to May 15th now.
Yeah, and the peak of cases in Massachusetts is supposed to be a little later than New York, and Western Mass is supposed to be later than Boston because we're more rural, right? And so the spread of the disease is just gonna be a little bit slower here. So, I would be thrilled to take high school students this summer. Hopefully we can work something out for you to physically be in the lab. It might be later in the summer rather than earlier, but maybe things could get started in like July or something. I'm trying to be optimistic about that. I can't guarantee anything, but if nothing else, we might be able to work out a plan where, you can learn like be an intern during the summer, but largely like learn and work and do things from home before stuff physically starts in the lab. Like I'm definitely open to that possibility.
That's great, Shelly. We are, on my end, the funding end, I'm pitching this as hard as I can to the state people who are in charge of it and telling them that you just give us the money, we will find a way to make this work.
Yeah.
And so I really appreciate your partnership and your willingness to just stick with it and be there to be creative and trying to find solutions.
Yeah, and I know the state funding might be a little bit tricky this year because everybody's a little bit nervous about when the economy is going to come back, right? And so I think the state and UMass is being a little stingy with funding right now, which kind of makes sense. But I really hope that we can get it to work.
Yep, that's great. Thank you. Who else?
Hi. Could you give an example of a high school student-oriented project in your lab?
Sure. Okay, so last summer I had a student working on traumatic brain injury. So we have another project in the lab that is using like the brain environments that we make to understand how forces or impacts can lead to chronic injury in the brain. And so she worked with a graduate student in my lab to look at a bunch of images we had of brains that were either healthy or had undergone trauma. And they figured out a new technique to analyze how you can tell the difference between an injured brain and a healthy brain. So they first started with like looking at the images and making this new analysis technique. And then they got to work with new tissues and cells and apply damage and then use her analysis technique to look at the effects of damage, right? So it started as like sort of training and data analysis, and then it went toward actually applying the experimental techniques to those tissues. So that's one project that we had. Another project was understanding what are the reasons why breast cancer metastasizes to the lung. So she was working with a graduate student in my lab who's making these lung mimicking synthetic environments. She learned how to do cell culture. She learned how to make the environments. She learned how to do microscopy. And then she was putting cells on these different lung surfaces, imaging on the microscope and trying to figure out what the proteins were that were causing the breast cancer cells to grow rapidly in the lung. So she first got a lot of training on some of the cell biology stuff and then was using microscopy to do analysis of these cells in lungs. Those are just a couple of examples of projects.
Pretty good resume builders for a high school student.
Absolutely. And I hope they're just having fun, right?
Of course. Yeah. The report back from kind of uniformly all the students that do get placed is that the experience it builds them in ways they hadn't anticipated. Their minds are expanded. They build the skills. They make new friends. And I think there's a big component of that, the soft skills that get developed. They realize, like, I don't have to be afraid of the world of work. It's manageable. I know how to act professional. We will do some training in that because there are instances, not specifically with our kids, but just in general, where people are doing things that they don't realize are not appropriate for the professional environment. But the kids just learn a tremendous amount by being in the environment of a place like UMass in the labs. It's really great. All right. Any other questions from folks? All right. Well, it looks like that might be it, Shelly. I really want to thank you for your time and your participation and just your ongoing commitment to working with us to meet the needs of these high school students.
It's been great for me too. I really enjoy having high school students in the lab. They think about things in a really different way than I do. So that's awesome. You know, and if people have any more questions that I didn't have time to ask me today or didn't feel comfortable asking me, feel free to email me. The email address is just speyton, Peyton, @umass.edu, and I'm happy to follow up. Okay.
Okay. Thank you.
I have a quick question.
Yeah, go ahead.
Good.
Can you take students that have worked with you again? Like, do you like accept like students that you worked with last summer?
Do I don't have an issue with that necessarily. I think maybe it depends on the any rules with the collaborative.
No rules here. We have some rules, but they don't restrict that. Yeah.
Because maybe you have some experience, right?
Yeah,
Working with Carrie.
Yeah, and I want to work with you again.
So we should talk about that some more, and I can follow up with Carrie as well.
All right. Well, thanks again, Shelly, and we'll
Happy
be
to
in
be
touch. Yeah, I'll reach out the more I understand from the state what's going to be happening. Okay.
Okay, sounds good. Yeah.
All
Thanks.
right.
Thanks, everyone. Great to see you. Okay, thanks, Matt, for having me. And,
Sure, absolutely.
let me know if you need anything else, okay?
Okay, thanks,
Okay.
Shelly. Take
Bye.
care.